So this YouTuber, the people of Earth, claims that you can see curvature at the beach. He's a peckerhead. So yesterday I uploaded a video on YouTube called The Moon Lie. And it was to explain a short video I made yesterday morning. Here in Colorado, I was standing on my deck. My deck faces the south. And it was about 9 o'clock in the morning, and the sun was rising in the southeast. And behind me was the moon, higher in the sky. You know, nothing between the sun and the moon. The moon should have been completely illuminated as a circle, but it's not. And so I made this video indicating that the sun does not light up the moon. And here's the short video. It's only like 22 seconds. And when I pan to the right to focus on the moon, you can see that the moon is not fully illuminated. And so the claim was that the sun does not illuminate the moon. You can see it's not fully illuminated. So after I posted the video, I got a comment from this Peckerhead right here. The people of Earth. This Peckerhead thinks he represents the people of Earth. And he's telling me this is only confusing because you're using the flat Earth model. Now, I'm not using any model. I'm looking at the sun above the earth and the moon above the earth. What I'm standing on is not relative because they're both above me. They're both in the sky, and there's nothing between them. So the sun should be completely illuminating the moon, but it is not. And of course, he goes on to say that this is absolutely not an issue with the heliocentric model. This guy's a peckerhead. He doesn't know what the hell he's talking about. Example one, he doesn't know what he's talking about. So, you know, we're going down a little further, and he tells me that the video doesn't mean anything until you apply it to a model. So we're looking at an observation of the sun and the moon up in the sky, and we can't really analyze what we're looking at unless we have a model. This guy's a peckerhead. He goes on to tell me that if he knows roughly, he could calculate the reason why this is happening if he knows my latitude and my longitude and the time of day. Of course, the time of day is on the video itself. It tells you it's 9 o'clock in the morning. I'm in Colorado, so, you know, I'm right outside Denver, you know. I mean, he could calculate my latitude and longitude and the time, but it wouldn't make any difference because they're both above the earth. It had nothing to do with imaginary latitude, imaginary longitude lines. Those lines don't exist. They're imaginary. Anyway, I tell him that this is not relative because the sun and the moon are both above the horizon. Any model concerning the shape of the earth, be it round, flat, or a Tootsie Roll, is not relative. Then this guy goes on to tell me something completely insane. He tells me, without a working model, you cannot demonstrate that you can understand reality. So I need to know what I'm standing on before I can look at the sun up in the sky and the moon up in the sky and see that the moon's not fully illuminated. I need to know what I'm standing on. I'm standing on a rock or something? What a peckerhead. Then he goes on to say, a simple panoramic photo of the horizon on a beach, you can easily observe the curvature. So what he's saying is that you can stand on the beach and do a panoramic photo and you'll see curvature. So I guess his camera, he's got the kind of camera that when you point it straight ahead, it doesn't see as far as when you point it to the left and the right. So we start on the left and the camera's seeing further on the left, and we start to pan the camera around, and when we get the camera directly in front of us, facing straight ahead, it doesn't see quite as far. Then we pan on to the right, and as we go to the right, it sees further again. So here we are with Google Earth. Let's see if we can figure out how this guy can see further left and right than he can in the center. So here we are. I mean, this is a ball Earth, right? This is a ball. But evidently his camera is special. Because I know the cameras can only see one distance all the way around in a circle. Now, you can zoom it all the way in and then pan, but it's not going to see further in any one direction. It's going to see the same distance all the way around. So let's zoom in here on the Gulf of Mexico. And let's use the measurement tool here. Instead of using a line, let's use a circle. So let's go down here and start our circle here. What do you know? Let's say it's a 30-mile circle. Well, let's make it bigger for demonstration purposes, all right? It's 100 miles right there. So we're standing here at the beach, and we zoom our camera out 100 miles, and then we turn it to the left, and all of a sudden it sees further. But when we go back to the center, it's still at 100 miles. And then when we go to the right, it gets bigger again, because we got a special camera. We got a camera that can see curvature. So it sees further left and right than it does in the center. What a peckerhead. The people of Earth is a peckerhead. He's an idiot. A camera sees the same distance in all directions. And if you're on a ball and you're looking out over the horizon and you see the edge of the horizon where the imaginary curve is, and you turn your camera this way, you'll see the same distance, the edge of the horizon on the imaginary curve. Same way over here. You're not going to see any curvature. Even if the Earth is a ball, you will not see curvature. You see the same distance in all directions. So our little dim-dim, Peckerhead, the people of Earth, is an idiot. Thanks for watching.